This is question 47 on chemistry from the 2020 IMAT. So we're told that there is a gaseous reaction involving substances P, Q and R, and that this expression gives the equilibrium constant for this reaction. And delta H for this reaction is negative. And so we're asked which of these factors below will independently increase Kc. And there is only one answer. So firstly, maybe it would be a good idea to think about what this equilibrium constant means and represents. So if this is a gaseous reaction involving P, Q and R, then could we write an equation for this reaction? So remember that for equilibrium constant expressions, the products go on the top, raised to their stoichiometric coefficients, and the reactants go on the bottom, again raised to their stoichiometric coefficients. And so from this we should be able to see that the reaction is Q plus 3R is in equilibrium with 2P. So these numbers have come from the powers of the concentrations. So this just helps us to better visualize what's going on in the reaction. So firstly, do we think increasing or in general changing the pressure is going to affect Kc? Well, what do we know about equilibrium constants? Well, they're called a constant for a reason, and one of those is that they are always independent of the pressure. And so, regardless of how we change the pressure, Kc, as a rule, is not going to change. So that means we can immediately mark A and D as definite wrong answers, because we know from our studies that Kc never changes with pressure. The thermodynamic reasons behind that are rather complex, but this is just a good thing to remember. So what about if we use a catalyst? Well, what would a catalyst affect in this situation? So a catalyst changes the rate or increases the rate at which equilibrium is obtained when the reactions are mixed together. But that, of course, does not actually affect the equilibrium constant because it has no impact on the actual concentrations of any of the reactants. It simply affects the rate at which equilibrium is achieved. And so using a catalyst will not independently increase Kc. So our final thing to think about is whether temperature will change Kc. We can see that it has to be one of these. And so what is the effect of temperature on this equilibrium constant? Well, we need to think about the enthalpy nature of this reaction. So we're told that the enthalpy change is negative. And what does that mean? We have an exothermic reaction which releases heat. And so again, another rule that we should remember from our studies is that for exothermic reactions, decreasing the temperature has the effect of increasing Kc. So we can see from applying the rules that we've learnt in our studies that C is the correct answer, that decreasing the temperature will increase Kc. So this is our final answer. So that's C.